Number 10. So f of x equals -3, x minus 2 squared plus 12.
What page is this?
Same page, 360. Thank you. Okay, same questions. Everything the same. Number 1, what is the shape? Maximum or minimum? Yes, yeah. Maximum because a is -3, which is less than 0, so the function has a maximum. Perfect. Very good. Step 2. Step 2 in this case, for this shape or for this type of function,
Excuse me.
is nothing else but what I see. I don't need any calculations. And you can already picture the graph in your head using transformation. So, what is the vertex of this function? Very clear, right? Because it's x squared, shifted to the left 2, vertical stretching by a factor of 3, a reflection, and then up 12. So the vertex is indeed 2, 12. Number 3, X-intercepts. If they exist, I don't want to waste my time. Do they exist? Yes. How many? Distinct. Awesome. How do I determine the X-intercepts? What do I have to write? Very good. So I have -3, x minus 2 squared plus 12 equals 0. I have 4 methods of solving this quadratic equation. Which one is the best now?
Completing the square.
It's already completed.
Oh man.
So the answer will never be complete in the square, ever.
I thought you said that was a problem or a certain.
It's complete the square. It will never be an option. Complete the square is used for the circle. Now we know. So what do I have to do? 4 methods. We have 4 methods. We studied them in chapter 2. That's why I'm asking you to review every weekend. You will never forget. If you find the time to redo the test with solutions in front of you or on the side every weekend, you will be so happy and you will not forget what we covered so far. You cannot be lost. We talked about these four methods a month ago. Okay, but it's already completed. The square is already completed. I will not factor because it's already factored. I will not use the quadratic formula because then I have to expand. So then what is left? So not completing the square, not factoring, and not quadratic formula. What is left? Because this is exactly, it's already set up. But I have to move 12 and divide by -3. So it's not cleaned up. So I have x minus 2 squared equals 4. Move 12, it becomes -12. Divide by -3, you get 4. You can't be confused. This is just really basic algebra, right? So now we take the square root. This is a very useful method. If you remember, I said complete the square, not useful for this. Factoring, how can I factor? It's not ready for factoring. Quadratic formula, no, it's not ready for the quadratic formula. So this is a typical situation for taking square roots. How many solutions we get? Good. What do I have to write?
X minus 2.
Very good. Awesome. So then I have x equals 2 plus or minus 2. I need 2 options, please. Yes, 0 indeed. And the other option? Awesome. So we have 2 x-intercepts. And they are? Awesome. 0, 0. Very good. Awesome. Very good. 4. What is my next item? Very good. But I already have it. But let's say, no, careful. That's okay. Let's say we don't see that. Let's say we don't see it. How do I find the y-intercept? Very good. Let's do it together. Ready? 0 minus 2. Negative 2. 0 minus 2 is negative 2. Negative 2 squared. 4. 4 times negative 3. Negative 12 plus 12. Right. So be very careful because now in this form, it's slightly more difficult to find the y-intercept. So here, this was easy to find for this function. It was easy to find the y-intercept 0, 0, 5. But the vertex needed calculation, right? We had to find negative b over 2a and so on and so forth. Here, in this case, the y-intercept is more difficult to determine because I have to be careful when I plug in x equals 0. However, since I got this value, it's clear that when x is 0, y is 0. So 0, comma 0. So I got that ordered pair. Okay, number 5, the axis of symmetry. What is the axis of symmetry of this parabola? I need x equals, you're right, it's x equals 2, the x coordinate of the vertex. Very good. So what is the maximum value? Yes, because it's this. Very good. And now I want the range. And you can say the range, we haven't even graphed it. Yeah, but we already have the graph in our head. Negative infinity to 12, awesome. Negative infinity to 12. Perfect. Thank you. We're ready to graph. We have all the information, no secrets whatsoever. So, one, two, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 12. So this is the vertex. I continue with the axis of symmetry, which is x equals 2, just to make sure that it helps. Actually, it helps keep the graph in shape. Okay, so 0, comma 0, 4, comma 0, and you gave me, that's it. The y-intercept is still 0, 0. So here's the graph. And this is the graph of f of x equals negative 3, x minus 2 squared, and plus 12. And is this function ever increasing?
Yes.
Good. For which x values? That's why we learned everything that we learned in chapter 2. For which x values? Perfect. For x values between negative infinity and 2, the function is increasing. Perfect. What about function decreasing? From 2 to infinity, the function is always decreasing. Perfect. Let's look at a word problem. Yes? Any questions? Any questions? Yes, Chris, go ahead. You wanted to say something? Yes?
No.
Okay.
Okay, no.
Yes?
Yeah.
Okay, so let's look at a word problem. Here it is on page 361. And let's look at problem 60. Okay. A ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x, the height of the ball is negative 0.8 x squared plus 3.2x and plus 6, where x is the ball's horizontal distance in feet. So this is the height, and x is the horizontal distance in feet. Both are in feet. What type of function is it? Does it have a max or a min? So I throw whatever. up and out. Yes. So let's say this is the picture. It may not be exactly this. I'm just talking about it. So in part A, what is the maximum height of the ball and how far from where it was thrown does it occur? So obviously, you already told me correctly this is a maximum. So we want to find this maximum and then how far. This could be here or it could be here. How far does that happen? Any questions? Go ahead. Horizontal distance. So this is the horizontal distance in feet. Yes, any questions? Go ahead. You may say something, you may have something on your mind that I haven't thought of saying. And you will help me too. Any questions? Okay. Good. So what do I need to determine? Did I say something wrong?
No, I said you're persistent.
Oh, on this?
No, about asking questions.
But I want you to, because otherwise why would I be?
I didn't have a question.
Okay. Good. So what do we need to do? We're asked to find the maximum height and how far from the launching side this happened, from the release or from the point where we throw it up in the air. So what am I asked to find?
The next height.
Say it again.
The next height.
Good. How do I do it? What am I really asked to find? The vertex, indeed. So the maximum point, that's why I asked first what function is it, and then if it has max min, and then when I'm asked to find the maximum, obviously I can only think of the vertex. There is nothing else. Perfect. So always pay attention to the sequence of questions because that will lead you to the correct answer. Good. So let's find the vertex. This is not the vertex type of form. So I have to find what? What do I have to calculate? Very good. Awesome. Negative. How much is B? Very good. How much is 2 times A? Negative 1.6. This is a distance. It better not be negative, right? How many negatives we see in this product or ratio? 2. So the answer would be 2. So 2 feet. So if the x-coordinate of the vertex is 2 feet, this is the horizontal distance from the release till it gets to have a maximum height. Now the question is, how do I find the maximum height? Of course. So I have to find f of 2. Negative 0.8 times 4 plus 3.2 times 2 and plus 6. So this is negative 3.2. This is 3.2 times 2, which is 6.4. Yeah, it's 4. You don't have to copy this. Just do it on your own, right? 6.4 minus 3.2 is 3.2 plus 6 is 9.2 feet. So this maximum height, 9.2 feet. Just plug it in. In any, you can use a calculator as well. How far does the ball travel horizontally before hitting the ground? Just tell me what to write. I know it's almost 6:15, so I have to stop in a minute.
9.2.
So this is 9.2. Part B. We're not going to finish it, but we're going to finish it next time. How far does the ball travel horizontally before hitting the ground? What am I asked to find? What is the distance? What is the distance till it hits the ground? No, no, no.
Oh, so it goes.
Thank
last
you.
end?
Very well. We have to find the X-intercepts. And in part C, and we'll come back on Monday to this. Part C, graph the function that models. We already did. Thank you. If you have any questions, please stay.